So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with transformations with a focus on enlargements where you've got a centre of enlargement and a positive scale factor. Now at higher level, along with the scale factor, you may also be given what is called a centre of enlargement, which I abbreviate as COE. Now this can either be a marked point or as a coordinate if your enlargement shape is on a set of axes. Now when a question has a centre of enlargement, the image needs to be in a specific place. So unlike the previous one where you just have a scale factor where you can draw the enlarged shape basically anywhere on your sheet of paper on the grid, when you've got a centre of enlargement it has to be in a certain place for you to get that mark. Now, when we can find the vertices of the image by drawing projection lines from the centre of enlargement through each of the vertices of the object. Now, a quick reminder that the object is the original shape and the image is the new transformed shape. Then by measuring the distance between the centre of enlargement to the vertices of the object and then multiply each of the distance by the scale factor and using this distance to find the vertices of the image. Now that may seem really complicated, so let's put that in an example to try and explain what that all means. So in this particular question we want to enlarge this rectangle from the scale from the center of enlargement that is marked on the screen. So here, this point here is my center of enlargement, my COE. Now typically the green lines would not be drawn, but you would need to draw those green lines first. So the first thing you want to do is draw the projection lines. And basically how I've drawn those projection lines is by looking at the vertices of each of these this rectangle. So I've got a vertex here, I've got a vertex here, I've got a vertex here, and I've got a vertex here. Now what I need to do is if I label these 1, 2, 3, 4, and what I need to do is I need to measure the distance from the COE to point 1. So with a ruler I'm going to measure that distance, and let's just say for argument's sake it's going to be 6 centimeters. So that equals 6 centimeters. So what I then need to do is I need to double that, and why am I doubling? Because my scale factor is 2. I'm going to measure 12 centimeters. So I'm going to add another 6 centimeters, and this here is my new number 1 for my image. So let's then measure the distance from the center of enlargement to point 2. So let me just get that color pen. So the center of enlargement to point 2. Let's just say for argument's sake that is going to be, well, let's go for 12 centimeters. So then what I then need to do is to double that, and again because it's scale factor of 2, so add another 12 centimeters from point 2, and let's just say for argument's sake that's going to be here, and this point here is going to be my new number 2. And let's then measure from point 0 to 3, or the center of enlargement to point 3, and again let's just say for argument's sake that that distance there is, let's say, 18 centimeters. Then what I then need to do is add another 18 centimeters from that point, or from the center of enlargement, double it, and this point here would be my new number 3. And then what I then do is repeat the process for number 4. So let's just say from the center of enlargement to point 4 is, let's say, let's go for 3 centimeters. And then this is also going to be 3 centimeters, and this point here will be my new hashtag 4. So now what I've got is I've got my vertices of my image, and what I'm then going to do is with a ruler, and I'm going to kind of cheat because I'm going to know it's a rectangle. Let's just get a color. Let's not go for pink, so we've done that one. Let's go for blue. And what I'm going to do is I'm going to draw a rectangle connecting each of those points and hope that it matches. Now your image should go through the projection lines in those respective corners. You might find this a little bit fiddly, only because it usually is, and again I've not properly measured, so you might find that my points are slightly out, but hopefully you get the gist. So basically what we then need to do is double each of these distance by 2, and again because we've got a scale factor of 2, so then the center of enlargement to, let me just write, so COE to hashtag 1 is going to be 12 centimeters. So again, that's going to be that distance there. The centre of enlargement to hashtag 2 is going to be 12 centimeters. Sorry, 24 centimeters. The COE to hashtag 3 is going to be 36 centimeters. And the COE to hashtag 4 is going to be 6 centimeters. And again, it's just a case of doubling. Now, obviously, I've made up those numbers, those lengths, but hopefully you get the gist of what you would actually need to do. Now, this method usually applies when you've got a plain piece of paper and you've got a centre of enlargement and you've got a shape. If you've got a grid, I'm going to show you a much easier way of doing the exact same thing, but so that it's less fiddly, because you tend to find that when you practice this way, your rectangle may look slightly like a parallelogram, your lines might not match up because it's all about accuracy, and unless your question is printed perfectly, i.e. the measurements are rounded to nice whole number centimeters, not like 0.2 of a millimeter or 6.3 and then you've got to double it or triple it, that's where it gets a little bit fiddly. So I would say more often than not, 99% of the chance you'll have square grids, in which I'm going to show you now how a much easier way of doing this on that. But this is the general purpose, and this is the way that you should be taught, because this is the way that they will be looking for to use when you're answering these types of questions in homework or in an exam. So just to reiterate that though it is possible to perform an enlargement with a centre of enlargement without drawing the projection lines, you will lose marks if you do not draw them. Now, if anything, they are useful to draw to check your enlarged shape is correct and in the correct position, which again I'll show you like a more shortcut way of working with these enlargements, but also drawing and using projection lines in a different but still a true way. Now, before we get started, it's worth mentioning that the copy of this worksheet with all the examples unanswered is available for you to download in the description below by clicking on the link, so in which you can work with me or you can work on the worksheet answering the same questions after watching this video. So looking at question 1, we want to enlarge this shape by a scale factor of 2, and we're also looking at a squared grid. So we're not looking at a set of axes, we've just been given some squared paper and we've got a shape. Now here we have got our centre of enlargement, which I'm going to label COE, and there it is. And I've drawn my projection lines through the 4 vertices of the object, which is a rectangle in this particular case. Now, typically what I want to be doing is I just label each of these points, is I need to measure the distance of the centre of enlargement to the vertices of the object. And so I want COE to the point 1, and the COE to point 2, and COE to point 3, and COE to point 4. Now let's just say for argument's sake that distance there was, let's say, well, I'm talking about the distance of each of these is being, without using a ruler I'm just going to have to guess, let's say that's going to be around about, let's say 3.8 centimeters. To number 2, let's say that's about 5 centimeters. To number 3, let's say that's 5 centimeters. And for number 4, let's say that's 3 centimeters. Again, I'm completely making these numbers up. Then what I then need to do is to multiply each of these distances by 2. So 3.8 would be 7.6 centimeters. That would be 10 centimeters. That would also be 10 centimeters, and that would be 6 centimeters. And what I would then do is, from my centre of enlargement, I would measure those distances. So for example, if that there is 3.8 centimeters, I need to measure another 3.8 centimeters, and that would be my new point, so to say. And I do that for all the same, and then until I get my actual place of each of the 4 positions. So for example, it could look something that looks like this, and then join the points up like so. Now, using your projection line at the very start can be very messy. It can also look very inaccurate as well. So I probably wouldn't recommend doing that. However, that is the correct way of doing this. Now, what I'm going to do now is I'm going to show you another alternate way that may seem longer, may seem like you do more work, but trust me, it is going to be a lot easier. And it's sometimes when you're with practice, you'll be able to do it in your head. And once you can do things mentally, it then becomes instantly a lot quicker. Now looking at and again, what you want to do in this particular question is use a bit of common sense. Now, as I always say, in the previous video, we just enlarged the shape by a scale factor. So here I've got my rectangle of my image is 4.3, 3 by 2. So on my enlarged shape, what's going to happen is I'm going to end up with a rectangle that's going to be vertical, and that's going to have a 4, and that's going to be 6, and that's the dimensions of that. Now if I know what the size is, all I really need to know is the starting point. Now to get that starting point, let's get rid of that rectangle, is I want to look at the column vector to get from the center enlargement 2.1, and that is going to be 3, 3. Now if I then multiply that by 2, and by 2 because it's the scale factor, I get 6, 6. And what that then tells me is if I go 6 across, which is going to be here, then 6 up, it tells me that my new hashtag 1, or the point 1 on my image, is going to be at this point. And then from that, what I can then do is I can then from there draw my 4 by 6 rectangle, which I'm going to try and draw more accurately using the range of colours that I've got. And what you should have, again, it's going to be very, very fiddly and not that, is something that looks like that. And you can see that each of the vertices of my image of the red rectangle go through the projection lines. So this would be my hashtag 2, this would be my hashtag 3, that would be my hashtag 4. And by drawing the projection lines, kind of just double checks, and it kind of gives the impression that you used your projection lines right at the start. So let's have a look at question 2. So question 2, here we've got a 3 by 2 triangle. So, and I want to enlarge it again by a scale factor of 2. So my triangle of the object, of the image rather, is going to be 6 up and 4 across. So again, what I want to do is find one point of this particular shape. So if I mark this point here, and that's got a column vector of 4, 3. So if I multiply that by 2, I get 8, 6. So starting at my center enlargement, if I then count 6, going to 8 rather, going to the right, and then 6 up, I get this point here. And then from this point, representing the top or the peak of the triangle, I can then draw the 6 by 4. And what I can then do is with a ruler, which I'm not going to get, I can then connect those points up like so. Again, you want to try and be as accurate as possible. Like so. Now, that would be absolutely fine, but I might lose a mark in an exam because I've not drawn my projection line. So what I need to do is draw my projection lines just to prove that the vertices on the object is also going through the corresponding vertices on the image. So just need to draw the other vertices, and as you can see, each of the vertices of the blue triangle are also going through the corresponding vertices of the red triangle, and that would be absolutely fine. Now, do you need to draw a projection line through every single one of the vertices? Probably not, but I will do at least 2 just to confirm that you have drawn it correctly. And like I said, if you've got time at the end of the exam, rather than twiddling your thumbs or looking at the clock, just counting the time down, I would probably then draw the projection lines for all the vertices, but 2 I would say would be a bare minimum. So again, looking at question 3, so here I've got a triangle that is 4 going across, and it's got a height of 4. So if I'm going to enlarge this by a scale factor of 2, then I'm looking at 8 with a height of 8. So again, all I need to do is pick a particular point to find out where the respective point is. So I'm going to go for this one here. So counting number of squares, I've got 1, 2, 3, 4, 5, 6. So to double that, I then need to go 12 from this centre of enlargement. So just count another 6 from here, and that would give me that point there. So if I now go 8 squares up, and then 4 on either side, there is my actual vertices of my image triangle. So connecting those points up, like so. And then trying to be as accurate as possible. Like so. And there is my enlarged shape. Now again, just to confirm, what I then want to do is draw my projection lines. So again, so from the center of enlargement, just go through the vertices, starting, and again, just making sure, and you can see how those two vertices of both my image and my object are on the same projection line. So it's all looking good. Then the final one, I want up there, and just for extra measure, just to confirm what I've done is correct, go through there. And there we go. And there's our third question completed. So I'm looking at question 4. So again, looking at this, I'm enlarging by a scale factor of 2. So looking at the dimensions of this sort of L shape, well, it's going to be 2, that's going to be 6, that's going to be 2, that's going to be 8, and that's going to be 4. So again, picking a particular point on the shape. So I'm going to go for this one here, which is 3 down, 3 to the left. So doubling that, it then becomes here. And then what I then want to do is just draw the shape. Now this one I'm actually going to draw freehand, which I'm sure I'm going to regret. It's not going to look perfect, just to save you from falling asleep. What I should end up with is something that looks like that. And again, just to confirm everything's all in the right place, I'm just going to draw my projection lines from the center to any two of the vertices. So if I go for this one here, and I can see it's just that. It's wide, right? Let's move this one there, so you can see that one's absolutely fine. That goes through those points that I got. And if I did another one, and there you go, you can see that it perfectly goes through points. And again, I could continue drawing those projection lines and it will go through, just to confirm that my image is in the correct place. And again, I strongly recommend you do use a ruler. So again, looking at the question 5, so again here we're using a scale factor of 3 this time. So looking at the dimensions of the box, we've got a 3 by 2, so my image is going to be triple that, so it's going to be 9 going across and 6 going up. So picking a particular point, so I'm going to go for this one here, so that's 2, 2. So if I triple that, I'm going to be going 6, 6. So that's 2, 2, 2, so that's there. And then 6 up is, and then from here I'm going to draw my 6 by 9 grid. So that's 3, 3, 3. And 6 up, 5, 6. It's going to be there. So there's my points. And if I now join those points up, so like so. So there is my join those points up, and now what I'm going to do is I'm just going to draw a projection line just to confirm that everything is in the right place. So like so, that's one that goes through it. Let's just do another one for good measure. And there we go. So again, that would be absolutely fine. Again, with obviously to save time, you would do well, to save time in this particular video, you would draw more projection lines. So looking at question 6 then. So again, I've got a 2 by 3 triangle. So again, I'm going to enlarge it by a scale factor of 3. So again, looking at this triangle, it's going to be 6 by 9. It looks like that. So again, picking this point here, I'm going to triple that distance, which is 3 to the right. So that's going to be another 3, so that's doubled, and that's tripled. And from here, I'm just going to do the measurement, so 3 across, 6 across rather, and 9 down. So that's 3 and 3. And then all I then need to do is join those points up. So again, strongly recommending use a ruler, which I clearly haven't. And again, you would then draw your projection lines. So now this one should fine. Check. Yep. Another one. And like so. There we go. And again, that would be absolutely fine. So again, looking at this next one, we've got a 4 by 1 rectangle that's laid down horizontally. And again, we're going to do a scale factor of 3, so it's going to be 12 by 3. So again, picking this point here, let's say the starting point, I'm going 2 to the right, 2 up. So I'm going to triple that, so it's going to be 6 across and 6 up. So that's 3 and there's 3, so that's that point there. And then from this I can then join my points. So 3, 4, another 4, another 4, 2, 4, and then just draw on a rectangle from here, a bit more accurate. And then again, with your projection lines, again drawing at least 2, I would say. So that's pretty much spot on. This one. See, that's it. Okay. Now again, just be careful of, as you can see in the center enlargement, I've completely, although it looks almost perfect, but again, you want to make sure that the all your projection lines go through the same point on your center enlargement. Having a large dot represent the center enlargement can make your projection lines look a little bit weird. So again, the shapes can get a bit more complicated, particularly when you move up in levels. So again, here I've got, if I just draw this trapezium, looking at some of the dimensions. So again, scale factor of 3, so that's going to be 6, 6, 12. So again, picking a particular point, so let's go for this one here. I'm going to triple the distance, so I'm going to, rather than go 1 up, I'm going to go 3 up, and rather going 3 across, I'm going to go 9 across. That's 3, 3, 3. So that's going to be my new starting point. So from this point, I'm going to go 6 down, 3, that's another 3, and then I'm going to go 6 across. So that's 4, 2, so that's like so. And from the bottom, I'm going to go 12 across. That's 4, another 4, another 4, and then from that, what I'll then bring those 2 points up. And then just to confirm that everything is all in the right place, what I'm going to then do is do my 2 projection lines. Just to confirm that looks fine. Just to level it up, it's fine as well. So again, the projection lines there just to confirm, and obviously use a ruler to make sure it does look correct. So looking at question 9 and 10, you can see here we've got a scale factor of 4. And again, we're looking at the triangle for question 9. We've got a 2 by 1 triangle. So again, enlarging them by 4 is going to be an 8 by 4. And again, draw my 2 projection lines is going to be fine. Then question 10, we've got a rectangle, a horizontal rectangle. And again, drawing, once you've got the dimensions of the shapes, and you pick in a particular point, draw your projection lines, and the corresponding vertices should be touching the same projection lines, and so you know that you've got it in the correct space. Now, if your enlargement is correct, but it's in the wrong place, then you'll lose 1 mark. So even if you're not quite getting the centre of enlargement, as long as you do enlarge the shape by the correct scale factor, you will get some marks, if not most of the marks, I should say, for that particular question. So looking at question 11, now this one's a little bit more tricky because the centre of enlargement is inside the shape. Now that has absolutely no bearing at all to the particular question of what it should look like. So here I've got a rhombus, and looking at the diagonals, then the diagonal is 2 by 4. If I'm enlarged this by a scale factor of 4, then that's going to have a height of 8, and it's going to have a width of 16. So from this particular point, or the center enlargement, I'm going to go 8 outwards towards the left, so that's 4, and that's another 4. So there's 1 point. Do exactly the same going in the left direction, that's 2, 4, 6, 8. And then going upwards, I'm going to go 4, so that's going to be there. And then going in the same, that's going to be there. So again, from this, all I then need to do is join those points up. So we use a more prominent colour. If I join those points up, and trying to be as accurate as possible through those points. This one just needs. This is what we're going to get, and then do the exact same for the others. This is kind of where you wish you had paper. And do the same from that point to so, and then final one. And you can see by drawing my projection lines, which let's just do that in green, that my projection lines is going to be going through each of those. As you can see, that's absolutely fine. And also they are all going through those corresponding vertices, which again shows that it is in the correct space. So it's just something just to be mindful of when you are doing these, that just make sure you are drawing your projection lines just to make sure it is going true. So looking at this little butterfly or bat or a W, as you may want to think about it as, so let's have a look at the dimensions. So here we want to enlarge by a scale factor of 4. So again, looking at this space, from here to this point here, it's 2 across, so that's going to be 8 across. That's 4, 6, 8, so that's going to be here. And going in the opposite direction, that's 4, and then that's another 4. Now this point here is 1 down, so we times that by 4, it's going to be 4 down, so that's 1, 2, 3, 4. And then the space between those is 1, so times that by 4, and that becomes there. Then it's just simply 4 across, 4 down, so that's going to be there. And 4 down, 4 across, that's going to be there. And then all I then need to do is join those vertices. So again, I'm going to do this freehand, which I'm actually no, let's use the correct lines, and let's use a more prominent colour. Let's go for green, and let's join those points up. Just going to kind of rush through these, so if you find that my lines aren't really going through my points, it's purely because of the software that I'm using. I'm sure you're probably screaming out that a lot quicker or use much better software. So, and then from this, all I then need to do is just do 2 projection lines. So let me just screen. And just do a projection line from there. Do another one there, and you can see again that that is absolutely fine. Again, if I had more time, then I would do more of all my construction lines. So for example, do one that goes down like so, and then one that goes from there to there. Actually, that one wasn't too bad. Then my final one there to there, and you can see that all the corresponding points hit the same vertices. And that is how you enlarge a shape using a center of enlargement when you've got a positive scale factor. Now obviously if my scale factor was a fraction, that's between, let's say, a proper fraction, then I'd be making the shape smaller, in which all you then need to do is do exactly what's covered in the previous video. Draw the smaller shape, draw your projection lines to make sure it's in the correct location, and you can go from there. Now we'll put this worksheet in the description below for you to have a go at this after watching this video, for you to practice everything that's been covered in this video.